Good morning. Today we're looking at Chapter 1 out of Business Calculus with Excel. We're looking at Section 2, Functions in a Business Setting. This is to review a number of kinds of functions you've seen in previous courses: quadratic, exponential, logistic, normal, and sinusoidal, and comment on them and just refresh them in your mind. Quadratic functions are second-degree polynomials. The standard example we'll use is the product of linear functions. If we're doing both revenue and profit, then we have quantity times a price, and the price is a linear function on the quantity. That gives us a quadratic function. We're often interested in the roots and the vertex of a graph and the place where it meets the x-axis. Exponential functions show up in growth. P equals a times r to the t, where r is a growth rate of some sort, and this will show up in present and future value of income streams. We want to distinguish the growth rate from the growth factor, the percentage increase from 1 plus that percentage increase. Logistic functions are constrained growth, that in the real world things don't grow without n, so we can't actually use an exponential function. It looks like f of x equals the saturation point times 1 plus a constant, depending on where we start, e to the minus rt. This is how we would write it in Excel. A sinusoidal function is one that repeats. They're trig functions. They're beyond the scope of this course, but they're worth thinking about because there are lots of things in life that are periodic, seasonal sales. A normal distribution is again a function that's an ugly looking function. F of x equals e to the minus quantity x minus m over s squared. It's daunting but doable with a spreadsheet, and there are lots of things that follow a normal distribution, a bell curve. Inversely proportional, f of x equals a over x, shows up when x and f of x, their product is constant. Think of the amount of material that goes into a box, and you have length and width. If you make the length less, the width can get greater. And logarithmic functions are the inverses of exponential functions. They have the form f of x equals k times the natural log. In looking at these functions, it'll be useful to click the link to the worksheet used in this section. There's an Excel worksheet that lets you play with the various kinds of functions and see what they look like as you change the constants. So that if I was looking at a quadratic function, I can see what happens if I change b, or if I change c, that's going to move the function up or down. All of the kinds of functions show up on that worksheet. Looking at the functions in a normal order, that we started with quadratic functions. Quadratic functions look like a parabola, and s and t would be the places of intersecting them. A says, is the function going up or going down? S and t are the points of intersection. I'm also interested in c, which is where it intersects the y-axis. The place that this will show up most, or most commonly, is something like revenue or profit, because I have revenue of q is q, something like 10 minus q. It's going to be times demand price. Demand price that has a negative slope, and so this would be something like revenue. A shifted version of it would be profit. So quadratic functions will show up often when we're talking about revenue or profit. The next kind of function we're interested in is an exponential function. This will look something like f of t is the principal times some rate to the t. These are functions that grow and grow more and more steeply as you go along. Examples will be money in a bank, so that my amount of money in the bank is the principal. I put $1,000 in, I get 3% interest raised to the power of the number of years. Um, this will also show up in something called future value, that if I make it instead, I have $1,000 that I'm promised somewhere in the future. I could have put the money in the bank for that many years. And so this tells me how much a promise of money in the future is worth today. So I know I'm going to get money, I'm just going to get it sometime in the future. The logistic curve is one that looks like it's trying to start out being exponential, but it peaks out, and we have a carrying capacity. If I'm looking at something like amount sold, amount of sales, if I come out with the neatest, newest thing, my growth starts out exponential, but eventually everyone in the world has one, and so it balances out, it levels out, there's a carrying capacity. So that's the logistic function. Two functions kinds of functions I'm going to mention that we really won't use much in the class are normal distributions and sinusoidal functions. Sinusoidal functions go up and down in a steady pattern. This might be something like seasonal sales, that if I'm selling Christmas trees sell really well during the months before Christmas, but they sell pretty badly in July. If I'm looking at selling electricity, there's a high electricity usage during the summer and the winter when air conditioning and heating are on, but a lower time during more seasonal times. The normal curve is the old-fashioned bell curve. People talk about grading on the curve. It also shows up in sizes of clothes and other things that almost all populations somehow fit a normal curve. So I'm interested in the normal curve if I'm saying I want to capture some portion in between and want to know where my product doesn't sell, whether that's airplane seats that are the wrong size, or I'm selling clothes and I want to know how much of size 9 and how much of size 12 I want to have. That's going to be broken down according to a normal curve. Two other functions that will show up: inversely proportional, f of x equals a over x. And the easiest thing to think of for this is area equals height times width. And so if I know how much material I want to put into a box, the height of the box and the width of the box are inversely proportional. So height will be area over width. And so we'll look at some functions where we're going to use inversely proportional functions. That means it's a constant over the variable. The last kind of function I want to look at is a logarithmic. F of x equals some constant k times the natural logarithm of x. If I have y equals k times the natural logarithm of x, that's the same thing as saying if y is the natural logarithm, is k times the natural logarithm of x. If I have an exponential function, the logarithmic function is gotten by swapping the roles of x and y. This gives you an example of some of the various functions that we'll be using. Again, my recommendation is to grab the worksheet that's attached to it and look at what happens when you change the variables. That on all of these, we're going to ask what are interesting points. And so if I'm looking at a quadratic function, the places where it intersects the axes, those are going to be interesting points, and the vertex is going to be an interesting point. If I have an exponential function, I'm going to look at how fast is it going up and how sharp does it bend there. So what happens at 1 and 5 will be questions I'll have, and where does it start out at 0? Those are standard questions I might want to ask. For a power function, I'm looking at what shape it is. This notes that Excel doesn't graph everything. It doesn't know how to do fractional powers. And when it gets confused, it just makes it equal to 0. The logarithmic function, as we see, is the inverse function for the exponential, that the exponential started out and went up sharply. The logarithmic flattens out. That's all for today. Thank you.